Mr. Jackson, for M1V1, should they do milliliters or liters?
Since milliliters will cancel out, it doesn't matter.
Okay, did you hear that? And then what's their M2V2? Because we already know that the molar.
You know the volume of the stock solution you're adding, and you know the volume it should be at the end. So there's V1 and V2. And you know the molarity of the solution because you made the solution.
Yeah.
So there's M1.
Okay, cool. Did you guys hear that? Cool. Okay. I feel like we need to get making jokes about this, but Addison Rae's new song on here, huh? Get me hype. Yup. No one laughed. Okay. So.
So that's actually the data we're going to collect.
Mr. Jackson,
You're welcome.
do I rinse these with the solution, like my dirty solution, and then I also rinse this with my dirty solution?
Yep. Okay. Or you can, if you just clean these, you can dry them out.
Okay, that's fine.
Okay, then you're good. You don't have to rinse them with the solution at all.
Okay.
But you can
Will you
rinse
help
that
me
with
with this?
yeah. So you want it like this, and you use the wheel. And as you pull the wheel down, the solution goes up.
Oh, okay.
Right, and we're going to do at least 5 milliliters. So we want to put 5 milliliters in there at least. And then when you press this button right here, it comes out.
Okay.
And that's the way we pipette.
All right, and then I'm gonna set that to 0, right?
Just like you did yesterday. Yep.
Okay.
But the cool thing is you're not messing with wavelengths, so you're going to be able to, once you make these, do these real fast.
Okay.
Yeah.
But I don't mess with this, the 100, right?
You do. You still need a blank, just like you did yesterday.
Okay.
You have to have it
With
zeroed
distilled
and
water?
100. Yep.
Okay. Alrighty. All right, I'm gonna put. Okay, I didn't clean that one.
You good?
Okay, volume tube number 1. These are not labeled, so I'm just gonna start. Guys, remember this for me. I'm gonna start from the left. So the very left one is 1. JK, I'm not ready yet.
Yeah. One milliliter. Okay, so never put that down because then it can. Okay, sorry. No worries. The pipettes and droppers never get held upside down, guys. I know it feels natural for us to do that, but always the dropper point down. Never otherwise. Are they figuring out the math for you? Yes.
Are you guys figuring out the math for me?
Yeah, do you mean like the math, like where like the calculations of CO, NO3, in each stock solution?
The M1V1 equals V2V.
Yeah, but I have a quick question. So, or like for the people in the Zoom, like, so for V2, are you doing 5 milliliters for the whole thing, or are you doing just what the H2O says?
I thought because the 5 milliliters is like how much of like your stock, And so I thought that would be V1.
Yeah, sorry. I've
Okay.
said it wrong.
I'm honestly not really sure what V2 is supposed to be, honestly. Because
Yeah.
that's just like what I need to figure out. Then like I can figure out M2.
V2 is, so V1 I think is the concentration. So like for test tube 1 it'd be 5.
Yeah.
For test tube 2 it would be 4. And then V2 I think is 5 in general because that's the amount.
Wait, could V2 possibly be 5 because it says volume after water was added, which would be like tube 1 has 0 volume or water added. So then
that
would it
makes,
be
that
5?
makes sense. Yeah.
So yeah, that's right.
I think you just like add the 2. Yeah, I see what you're talking about.
I'm not following, but it's okay.
So V2 will always be 5.
Yes. Right, Miss Benson? V2 will always be 5.
Right?
Yes, because that's the amount that we want.
5 liters.
That's the 5 milliliters, yes.
Okay.
Okay, so test tube 1's done. Now I'm going to do 4 milliliters of our stock solution and then 1 milliliter of. Okay. This is a weird thing.
So just to clarify, V1 changed according to which test tube we're doing.
Yes.
Okay.
Yeah.
Got it? Is there a certain amount we can put in the blank or does it not? 3/4 of the way full? Yeah, 3/4 of the way full. Not all the way to the top, 3/4 of the way full. Yesterday she had it, so it's like actually hanging over the top.
Okay, hold on. I'm gonna dry this.
I get you.
This last one, because this is gonna be our blank. Wait, can our blank look like this? Gonna be a different shape than our other ones?
No.
Oh, well then I only
You
have.
don't, and real quick, make sure we're all on the same page. You don't use test tubes in the machine. You only use cuvettes in the machine. The test tubes are just to hold it. So if you don't have cuvettes, you'll have to get cuvettes again. Just like
Oh, okay, I have a that. Hold on, I feel like I have a sword. And if I rinse my blank with distilled water, that's cleaning it.
That's fine, right? Because the blank needs to be with distilled water. It's gonna hold distilled water, right?
Yes.
But that should always be vertical so that the point is down.
Okay.
Not like you have it like under your arm. There you go.
How do I like?
You can just set it down like that.
I didn't know if I could set it down.
Yep.
So.
The thing you can't do is have them upside down.
Okay. Here's our blank.
Five. And 1, 2, 5 is pretty good.
Okay, I'm cleaning this one so I can put our distilled water in it for our solutions.
Lily has a question for you, Mr. Jackson.
What?
Lily has a question for you.
Who? Lily? What up?
Lily. What's that?
Yeah, we can't hear you. Probably louder in your headphones. Because you don't type it in the chat.
Lily, type it in the chat.
So if it goes to 10, that's 1 milliliter, right? Because mine's like backwards.
Yeah, there should always be some at the bottom. So if you go all the way up here, that's 10 milliliters. So that would be 9, 8, 7, 6, 5, 4, right?
But this is 1, right? Because it's at the 10 mark. That's 1 milliliter.
Yep. I think, is there 9 lines? 1, 2,
Yeah.
3, 4, 5, 6, 7, 8, 9, 10. No, that's how much will stay in there at the end, I think.
Oh.
There's 10 lines.
Oh my god. Wait, so should I fill it up till 9?
On page 5.
That's
Well, yeah, we're adding them together. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, right?
All right, look at my head.
What? Yeah. You had bubbles yesterday, you forgot it, yeah.
okay, solution 2 is done.
That was all over yesterday. It's like this AP class I'm teaching, there's some stuff I haven't even seen.
Wait, you just did test tube 2 or test tube 1?
Test tube 2.
Okay, and then for the like you put how much in the water or how much water?
You like go like this down, and that makes it go in. And then if you need to release it, you do this. You push this down. Sorry, go ahead, Raylan. I mean, Maya.
Okay, so like you do like how much like water did you use? Like just 1 milliliter, right?
Yes. Okay, that's 3 milliliters. So now I'm doing test tube 3, and I'm doing 3 milliliters of our stock solution. And I'm going to do 1 milliliter of distilled water. Or I mean 2 milliliters of distilled water.
And then don't we write down like the absorbance, kind of like what we did with the wavelength, or is that like something
That's
else?
what I do after. I'm doing that after. Now I'm just making my solutions.
Okay, cool.
It's filling it all the way up to here.
Yeah, that's the thing, it's analog, so there's gonna be like, you just keep twisting it until it works.
It's filling it all the way up to here, Sandra.
Yes.
Oh my god. This bubble.
You might need maybe fill that up more or something. You gotta be like under. It has to be under the surface.
So now I'm doing 2.
Oh, what's the last ball start?
The more fun.
Whatever works, right? We'll get through it.
I'm just trying to like not. Oh shoot, I missed one thing. Oh, I messed up. Oh, sorry.
So right now I'm doing
That was after period already.
oof. And I'm doing stock solution 4. So I just filled up 3 milliliters of distilled water and 2 milliliters of our stock solution. Okay, now I'm doing stock solute or tube number 5. Oops.
That's tube 1. I got absorbance of 0.36. You always do that calculation for M151 and 2.
And when you're doing M2, all that stuff, I think we're finding M2. We already have M1.
What's confusing for it?
Or we're finding one of the M's. I honestly can't remember.
We're finding the second molarity.
Okay.
But what would the first molarity be for like, oh, it's just wait, I don't know what the first molarity would be.
It would be 0.2.
0.2.
For
Because
all
that
of
was
them?
No.
that was the
Also, Olivia, I'll send you the M2s in the chat so that you can write it down.
okay.
I have no.
Can
Wait,
you just send me like a picture after class? Because I'm not gonna have time to write it down probably.
can you send me a photo? Because I'm confused how to find it.
Yeah, I can send you guys the photo.
I'll ask him.
What is molarity again?
Mr. Jackson, our M1 would be this, and then would our V1 be 5 milliliters, or however many milliliters of our stock solution I use?
What is it?
What?
What is it? What is M1? The
M1
concentration of what?
0.20.
There you go.
This.
Yep.
But V1, is that 5
That's
milliliters?
how much you put in of the stock solution,
Oh, okay.
because that's the molarity of the stock solution, right?
Okay.
Yep.
So V1 is how much milliliters I put in the stock solution. So V1 for, let's say, test tube 3 would be 3 milliliters.
Because
And then V2.
It's a physical thing in front of you.
Well, yeah, I can do the math, but the thing.
Well, I thought V1 would always be
No, it's not. I just asked him.
So we're only talking about not the water, only the stock.
Final solution, right?
Huh?
Yeah, V1 is stock, but I have a question. So, Olivia, you started with 1 milliliter of stock, right? I mean stock.
No, I started with 5 milliliters stock and 0 milliliters.
Thanks.
Okay, so sorry. I had them confused, but they're both 5.
Okay.
Where did we get 0.2?
Yeah, it's just.
That's when the other lab, the lab we did last week.
Oh, okay. Oh, the molarity of the. Oh, okay, I
The
remember now.
solution I'm using.
Yeah.
For each other test.
Come on, water. Okay. Jeez. Okay. Our solutions have been made. I'm dumping it.
So you're gonna put 0.2003 times 4 milliliters equals 5 milliliters.
Okay.
Yeah.
Where's my cuvette?
Yeah, it's
Where did she go?
0.2003
So I should clean this out first.
milliliters.
Should I clean it out with the molar? Like, this is the cuvette that I'm gonna put these in.
Is it the one? Okay, so yeah, just put a little bit of, actually, if you can dry it, that would be best.
Okay. And we're just doing the same kind of thing we did yesterday. We're still finding the absorbance. I'm still doing the same procedure. Okay.
Same thing, yeah.
Sorry, I'm just trying to make this solution to the water and the stock solution. Right now, I don't really go into it. Because
You're fine.
which thing do you know?
Yeah, it's just a divider.
And, so, do you guys have a graph made in Excel? Ian?
We have, what do we got? We have the maximum wavelength graph.
Do we need to make a graph for each of these solutions? Have you guys figured out the concentration of each of these? Using the solution formula? What's that? Yeah, molarity is the concentration. So you're finding M2. And then once you have those concentrations, that's going to be your concentration will be on your X of your graph.
So for
And absorbency will be your Y.
it's like the number
And the variable is the
Okay, so once you guys find all the concentrations, which is the M2, write it all down, because then once I find the absorbance, we're gonna make a graph of that. I'm listening in on him. Do this. Okay. This is 0.
spot. And then you need to figure out the concentration for solution test tube 2, 3, 4, and 5. And then she's going to give you the absorbencies of those.
Yes, I'm sorry. It's really hard. Yeah.
Any questions? Does that make sense? Or no?
Yeah, we did. Just gotta get the graph set up.
Okay, yep, and just make that in Google Sheets if you can. And then just share the link on here in the chat or something. That way you guys can all look at it at the same time and all have access to share it. Does that make sense?
Yeah.
Okay. All right, ready?
And then.
Oh, wait. Just kidding. I'm not ready. Oh, man.
Unknowns? No, she's gonna get the unknowns today too. I'm
I
finishing
just
it.
want to start.
She's got 27 minutes.
I just finished up setting.
You need to do that. Yeah, those-
Okay. This is number 1. We have to get the enums. What's that? Okay, this is stock solution 1. Okay, for stock solution 1, the absorbance is 1.045.
On number 2, did you guys get into 1.504? Bet.
Yeah, right.
I'm doing the absorbance right now. I'll use them all once we're done with this.
It doesn't matter how much, does it?
3/4 of the way.
Oh, right.
No worries.
Ms. Jackson, I have a question.
Mm-hmm.
Every time I take my stock solution cavet out of this, every time I take the stock solution cavet out, do I put the blank back in and get to 100 again? Or do I do that?
It should always be 100 when you put it in there. Yep.
Yeah, but do I need to get it to 100?
You need to make sure it is. Right? Make sure it's a 0 and 100, and then you take it. Yep. It shouldn't really change, but it looks like it did for you.
Yeah.
For tube number 1. 5.5.
Okay, tube number 2.
Got that? Do that right away.
Fingerprints. Okay. For stock solution 2, or for tube number 2, it's 0.870. That's the absorbance. And Maya, will you just send me all this after? I'm not writing any of this down because I'm just trying to get it done in the period.
I'll show you the model.
Okay. For tube number 3, it's 0.630. Oh, that's not lined up.
Okay, so now I'm gonna do the next one.
Okay, now we're on to tube number 4. Get out.
Okay, how do I go?
All right, I got the examples. So the first one is 0.360. Testing 1 is 0.360. And then test tube number 2 is 0.329. And then the third test tube is 0.283.
What is all of this? Then you're good. Yeah.
Okay, solution 4.430.
Yeah, pull that up. And so then the first one is 0.360. Number 1. Yeah. And then it's 0.329. 0.283. Give that 4. And then 0.211. And then 0.097. Alright, what do y'all get for the yeah, can you all give me the molarity? I don't have that. Yeah, that's the even.
Okay, last one.
The unknowns are right here. Just pour into the beaker and then pour into your cuvette whenever you're ready.
Oh, okay. Okay, so the second one is 0.788.
Okay, so the first one.
Yeah.
The first one is 0.2003.
Alright.
Second one is 0.104.
Okay.
Okay, last one. 2.16.
Okay.
The fourth one is 0.5008.
Alright.
Alrighty.
0.216 or 2.16?
0.216, sorry.
Okay, thank you.
0.002.
Just 1.002.
Yeah.
And is there a 0 after that?
Okay.
Yeah, you're fine.
All right, that's it. Oh, Jesus. I made
Now
this.
we create a graph of that.
Okay. Let me clean up and then.
We can do that on the same one.
Okay. Yeah, I think so.
But I'm kind of confused about like 4 and 6. Like, what is? I'm not sure about the unknown solutions. Like, are we supposed to be doing that today or no?
Oh, I don't know.
I
Hold
mean,
Mr. Jackson. So when I'm done with these, I do the unknown.
Yep. You got 3 unknowns right there.
I do the same thing again.
Yep. What? It's easy, isn't it?
okay, we can just do the graph.
You use all 3. You do each one separately. You don't have to dilute them though. All you do is pour that in the cuvette and go from there. No, bring your cuvette up here. Right?
And do I use the cuvettes?
The same blank and the same cuvette. Yep, all the same. What up? Excel, yeah. Concentration.
Okay, just kidding. Now I do it to 3 more solutions, but it'll take a lot less time because I don't have to dilute them.
You're going to want to put the Y values for the absorbency we got, and then the X values for the molarity. And then you can make that graph on like Excel or something. Or we can draw by hand.
Should I dry my cuvette before
Just
doing
like
that?
before, right? Just like before.
I might just write that.
Oh my god, guys. Why
I'll do that at home later. So you see stuff.
a big stressor?
Just enough to fill the cuvette 3/4 of the way. Easy, easy stuff.
It's not.
You ready to test those?
Is there a place to write like where the unknowns and stuff?
Yeah, there is. And then I also think that when we find, I think you have to find M2 or something like that. Or never mind. Wait, no. Just kidding. Sorry, never mind.
Okay.
Alright, so I got the first one here. Hang on. Set it in the sheet.
Right?
Ugh. This knob.
This should be 100.
Sorry, guys. Let me run my cuvette.
Right? So then you have to take perspective to do that, right? Basically, all you should be doing is pouring this into here and then dropping it down into there. Then doing the same thing again.
Okay, for solution, the unknown solution number 1, it is 0.151. That's 0.151.
That one's still playing it, right?
No, not with this one.
Alright, so for unknown solution 1, the absorbance I got is
Can I-
0.083.
I'm just gonna dump it. I think that's what you do. I hate drying them. It's like the worst.
I'm checking it again. I think I did it wrong.
Milton.
It's actually 0.092.
Oh my god.
Alright, so that's the first one.
Maybe I'm not sure to change those because like I think maybe when I like put pressure on it, like,
On the thing?
I'm pretty sure because it keeps changing and I don't change it like so I don't know what. Okay, that's. See, whenever you put pressure on it, it's changes. That's why you don't change it. Okay. Okay, so the fourth one is 0.462. Yeah, I'll type it in the chat. 0.46.
Also, like the wavelength switched to 511 instead of 510, so if we can write that down for like our percent error or something. Because it switched a while ago and I wasn't going to change it because it's 1 off. I don't think it's that big of a deal.
Oh, look at it. There we go.
Alright, I'm setting up for the second method now.
Okay.
Okay, so this is the last one. The last one is
Got it.
0.
Okay. Solution number 2 of unknown. The absorbance is 0.079. dump it. Try it.
And basically you take the cuvette, you bring it over here, you fill it up. This is unknown number 1.
Okay.
What's up? 1 point.
Also for the unknown solution, make sure you record the unknown sample. Wait, Mr.
That's number 1. That's unknown number 1.
I don't know where.
Just give it.
No, I know, but like,
Right down.
okay, so. for the
Okay, guys. Number 3. We're almost done. Last one. Absorbance. Okay, solution unknown number 3 is the absorbance is 0.420. Okay. All done. Dry this.
Unknown solution number 2.
Wait, so how do we do the last part? Like, there's all-
Yeah, that's not gonna work.
How
Whatever.
do we do number, like, part 6?
Is that the unknowns?
Well, I got the, it says like if I have them on a graph or something.
Yeah, put them on the graph.
And then so are we supposed to give them a layer?
Yep.
Oh,
Okay, so we're also
Because it
supposed to.
should be on the graph somewhere.
oh,
Did you break it?
Wait.
yeah, so you have to-
I guess we're also supposed to get the molarity of the solutions, but I don't think you do that with work. He said it should just find it on the graph.
Yeah, so we have to plug the absorbance on the graph, and then you should find the M2.
Okay. Right. The period's gonna end pretty soon. But if we have all the stuff on the graph and you guys did all the solutions, thank you for that.
1744, 42, 44, 1744. All right.
Yeah.
Wait, Mr. Jackson. These are all of these
Yeah, right. It's gonna be harder. But that's the thing about doing a hand graph. I mean, that's all a hand graph is, right?
I can get rid of my solutions, right? Oh my god.
Yep, you're all done.
What about the solution I originally made? That too?
Yep, you're done with it. You got what we needed.
Cool.
You guys ready?
So we should only have the absorbance, right? Not the.
Yes.
What was the second one?
Oh, I don't know. I didn't write anything down. Maya, do you know?
0.079.
The with the absorbance of the unknown number 2.
Wait, so it's 0.15, 0.79?
Test tube 1 was 0.151, and then test tube 2 was 0.079.
Oh, 0.79, and then the last one was 0.042 or 0.420?
Yeah, 0.420.
Oh, that's weird.
Go through the origin. Zero concentration.
Okay.
So do we just look on the x-axis to find M2 for the unknown, right?
Yeah.
Okay.
Two more.
I don't know what I would have done wrong, so that's gonna.
You have one more?
Yeah.
You guys have all the unknowns done? Peter?
Yeah.
Alright.
Oh, I see. Where should I put the empty beaker or the empty?
Just come down the sink and then rinse that out with distilled water and put it back over here with the rest. It shouldn't be. What do you mean? Beyond the graph?
But they don't have it right now. It's like,
Yeah, they need to extend. Yeah, you have to extrapolate the graph out
yeah,
there.
just like extend it on the same like slope and then.
You got it. You have to extrapolate it out.
All right, that's the bell. If any of you guys need help, you can I don't know, you can email Mr. Jackson or something, but I think that should be good.
So we do the rest on our own.
Yes.
Okay.
All right, bye.